Right, thanks everyone for coming along. Now we've sorted out the audio-visual issues. Better tell you about my proposal, which is improving Savanna fire management capacity through participatory geosimulation and 3D tactile geovisualisation. Now it's a particularly sort of convoluted and nonsensical title, as many people have told me, so I guess the point of the presentation today is to explain what that actually means, what I'm going to do, why it's worthwhile doing, and the fact that I want to try and convince you that I'm capable of actually doing it. So I'm going to provide a bit of some background as to how I came about doing this, a little bit of a journey to get me there. Talk about some of the main issues, Savanna fire management and tools to support Savanna fire management, and the different sort of research themes or methods around fire extinction, fire spread modelling, 3D visualisation, and how I'll be developing that through a range of collaborative applications. So I started working as a remote sensing spatial scientist around 27 years ago now. I was working in Canberra for CSIRO, and I worked with two scientists at that time who were at the forefront of developing remote sensing applications for monitoring in Australia. The first guy I worked with is a fellow called David Jupp. He was a brilliant physicist and mathematician, and he was developing some of the first algorithms for monitoring landscapes and rangelands in Australia. Then I went on to work with a fellow called Dean Gratz, and he was at the sort of the polar end of the scale in terms of character type. He was a real sort of showman and agitator and communicator. I worked with him from 91 to 92. 92 was the International Year of Space, and we worked on a project called Looking Back, the Changing Face of the Australian Continent. And this was the first ever continent-wide land cover change assessment. And Dean being Dean, instead of doing sort of this dry quantitative survey, he produced this massive coffee table book. I don't have a copy here, but it's about this big. And each page had a double spread of these large Landsat pictures showing landscape change between around 1972 and 1992. CSIRO refused to publish it at the time because the text that Dean wrote was trying to stir things up, which he did successfully. But you can see the image on the front actually is of Catherine. So it was a while later I ended up back in the Territory. But yeah, so that working with Dean at that time really sort of, I guess, made me understand the power of imagery, and particularly geospatial or satellite imagery for communicating landscape processes, scientific issues, and helping people to understand environmental impacts that we're having in the landscape. So a few years later, around 95, I came to Darwin, started working with the Northern Territory government up here with some of my colleagues I still work with now in the Darwin Centre for Bushfires Research. Then I moved down to Alice Springs for a year working on a participatory mapping project with the pastoral community, developing techniques for mapping land systems with Landsat. So moving on, I've been working at CDU now for about 13 years, mostly in eastern Indonesia, and for the last 5 or 6 with the Darwin Centre for Bushfires Research, producing all the fire mapping for the Northern Territory and the Kimberley for the Northern Australia Fire Information website. And I hope most of you are aware of that website. If you're not, you should have a look. It's the premier portal of fire information that most land managers use across Northern Australia. You can see the picture up in the top left there. That's when I started work at CDU 13 years ago, when I was slightly less cranky and slightly handsomer, I guess. But a lot of this work has been based around, both in Indonesia and through NAFI, is based around bridging technical scientific skills with on-ground experience, and trying to decentralise the capacity for evidence-based natural resource management and planning. During this time, in the early 2000s, I was also working as a multimedia consultant exploring 3D digital multimedia projects for communicating science and landscape projects. And during that time also we started to explore 3D tactile representations of the landscape for supporting participatory engagement, science communication. So you can see in the bottom picture there is this paper mache Mwangi landscape I made. There's an area in East Arnhem Land for some work that is being done out there for a land management project. So this all sort of relates back to my work now with NAFI, which, as I mentioned, is the premier sort of website that everybody engaged in active land management in Northern Australia has as their homepage throughout the majority of the early dry season and late dry season when they're monitoring fires. So it's a great example of applied GIS and participatory GIS as well, because I'm always getting feedback and comments from land managers who are using this site telling me what's going on. But at the moment it's really one of the only tools that we have available to support fire management across Northern Australia. So Savanna landscapes in Northern Australia are vast, fire prone. They support multiple environmental and livelihood benefits, and good management is key to sustaining these benefits. And there's new opportunities to improve fire management across Northern Australia with the growing carbon farming industry. I'll talk about these things in a little bit more detail later. But the important thing is there's currently no formal training and very few resources besides NAFI focused on building skills and landscape scale fire management in Northern Australia. In Northern Australia, almost anyone can engage in burning operations across landscapes regardless of training, skills or experience, which in contrast to Southern Australia, most on-ground mitigation burns are done by agencies and trained professionals. And I guess importantly also, fire management occurs across Australia by a diverse range of people, highly variable sort of education and cultural backgrounds. So I think it's critical in order to improve landscape scale fire management that appropriate tools and capacity building applications need to be developed. Okay, about 5 or 6 years ago, I came across this mob in California called SimTable, and they developed this technique of using 3D, using sand pits to create 3D terrain models, and then projecting over the top of that simulation models of landscape fires. And it was such an engaging and captivating way to try and understand the way the fire was moving through landscapes. I could see that there was an application for this in Northern Australia. At that time, I couldn't see how I might be able to emulate it. It just looked too sophisticated and a bit too beyond my skill sets. But I could just see where that would fit in within Northern Australia. But fortunately, around that same time, I joined a workshop in payment for environmental services and met a fellow called Scott Heckbert, who's an environmental economist and modeller from Canada. And he introduced me to this piece of software called NetLogo, which he was using for his payment for environmental services modelling, and convinced me it was such an easy open source tool which enables the input of spatially explicit or GIS data sets to visualise landscape processes and create these interactive tools to build capacity and understanding what's going on in the landscape. So I started playing around with it a bit more. I found this model, which is the background here. It's you'd call it a cellular autonomous model of fire spread. And you might be able to see these little cells. They sort of propagate fire across the landscape. And that got me thinking I could link this back to what I saw the SimTable people doing. So I started playing around a little bit more and inputting my own data sets that derived from NAFI and areas I was working with, and started doing some bit of background reading. And I realised what I was doing was not cellular autonomous modelling as such. It was more appropriately termed geosimulation, because I was using these spatially explicit data sets. So the rest of the presentation I'll be referring to the model in this format using NetLogo as a geosimulation modelling. Okay, and started playing around a little bit more, started playing in sand pits, which was a lot of fun, and working out how I could try and emulate that sort of 3D display. My colleague Scott, who introduced me to NetLogo, saw me playing in sand pits and he thought that was great because he was in North America, where everyone's 3D printing everything these days. He went and bought himself a 3D printer and he started 3D printing landscapes. So this is wrong way. So this is a sort of 3D printed landscape. This is the first landscape he printed, which was of Nibbaluk National Park, based on the modelling work that I was doing. So earlier this year I spent a couple of weeks in Canada developing those 3D printing skills. I've got an example of a 3D printed model that I printed more recently here. I I was going to do the whole sort of show, the whole setup today, but I sort of didn't quite have the time, so it might be another presentation. So geosimulation is the modelling format that I've been using to develop these fire spread models, and the geovisualisation is this sort of projection or augmented visualisation process. And for me, this was just really interesting because it was combining all these areas of interest for me, which was participatory GIS, the 3D participatory GIS that I started with that Mwangi model, and geosimulation. So I'm calling it participatory 3D geosimulation. And I was having such fun with this, and I'd been at the university for 13 years, so I thought I should do the right thing and start a bloody PhD. And if I'm going to do a PhD, I might as well do it playing in sandpits and something that I find fun, I think it's worthwhile, and I have enthusiasm for doing, so that's why I'm here today. So what's the point of my PhD really? What's the objective? So the study really specifically seeks to support improved fire management across Northern Australia through conducting research that will build a better understanding of the factors that affect fire spread and extinction in Northern Australia, develop a model of fire spread at a landscape scale to support practical on-ground management planning, and also developing innovative 3D fire planning visualisation tools that bring the available data into a practical teaching and planning formats. I mean, it's an issue that I've seen with NAFI. The data there is great and there is a lot of tools in there, but I'd say only 10% of NAFI's capability and the data that's in there is used by land managers. So I'm really trying to think of ways that we can take that sort of all the great data sets that we're producing as scientists and put it in a format that really engages people. Next, there we go. Okay, so I'll just go through briefly the importance of some of the work that I'm engaging with. So the importance of Savanna fire management in relation to biodiversity, greenhouse gas emissions, regional economies, and the importance of understanding fire behaviour, and particularly fire behaviour as a complex system, and the importance of developing these tools. So I won't harp on about Savanna fire, because I'll go through it quite quickly because I'm hoping 80% of the people here already have a bit of an idea of its significance, but I mean, as you can see from this image, it's a satellite-derived data set. The vast majority of fires in Australia occur in the Savanna landscapes, around 23% annually, as opposed to southern Australia, which is less than 1%. What is of real concern, though, are the hot, late, dry season fires. These are large fires, and they can have quite severe impacts on biodiversity greenhouse gases. So biodiversity in particular, these large, late, dry season fires have been shown to have significant impacts on a range of flora and fauna, including Gordian finch. I had to throw in a picture, a painting from my wife, because she's a very talented wildlife artist. But anyway, this is a Sandra Kendall exclusive. So the Gordian finch its population was impacted quite severely by these large fires, reducing its access to feed from grasses. I think there's been a rebounding in the population more recently, specifically related to improved fire management, particularly in the Kimberley. I mean, this is a picture of what a late, hot, dry season fire is. There's no food, there's no habitat, and particularly for some of these smaller mammal species like quoll or the beautiful brush-tailed rabbit rat, with these small home ranges, they've got nothing to eat, no habitat, so they disappear from some of these environments. Similarly, with some obligate seeding plant species, such as the rock myrtle or the cypress pine, it can take quite a long time for them to reseed, so high fire frequencies and high late dry season fire frequencies cause local extinctions of these species. Greenhouse gas emissions, I mean, Savanna fires contribute between 2 and 4% of the total inventory from Australia, depending on the season. This is based on counting those long-lived gases such as methane and nitrous oxide, and would be substantially more if we included carbon dioxide in the accounting. And once again, a lot of those emissions come from late dry season fires. So here's a picture of what we call a cool burn. You can see there's not a lot of smoke coming off it, and they're fairly low intensity, no crown fire, and they're fairly patchy as well. So less carbon emissions and more opportunities for little birds and animals to run out of the way, climb a tree or whatever they do. Okay, so how do we reduce the number of these large deleterious fires? And it's through strategic use of early dry season mitigation burns. So across the whole of North Australia these days, there's most land managers engage in some sort of early dry season mitigation burning to reduce the intensity of the fires. The idea is to create a patch mosaic or contiguous fire breaks across the landscape. A term which is useful when thinking about mitigation burns is leveraging. And what that means, I mean, I can explain it in the context of the southern eucalypt forests of Australia. So work done by Owen Price and others found that for every hectare burnt in a strategic mitigation burn in southern Australia, you'll reduce wildfire burns by a third. So for every hectare, you'll have a third of a hectare reduced of wildfire burns. In contrast, in northern Australia, they found the leveraging value closer to 1, whereby strategic dry season burning reduces late dry season fires, a direct one-to-one replacement. This work also suggested that more strategic burns could have an even greater leveraging value. So the efficacy of mitigation burns in Australia is 3 times more than in southern Australia. So Owen's work has also looked into the efficiency of the early dry season burns for stopping fires, and he's found that 95% of the time those early dry season burns will pull up later dry season fires. Most of the work is done by helicopter, aerial and incendiary burns. This image here is actually a bit of the East Kimberley, and you can see the incendiary burns. They're like lines through the landscape, and it's great as I do the mapping through the year. It's like seeing people painting the landscape with fire. But you can see how they've put in these quite strategic burns, and they've gone back there to try and buffer those burns a little bit more. A lot of the strategic burning is commonly building on naturally occurring breaks, whether they be river lines, natural draining lines or cliffs. So that requires a lot of local knowledge to understand how to get the most effective burns. So the impact of this, all of this burning across northern Australia, I mean, there's mining or cattle, but now there's this growing industry in fire management. So in 2012, the Australian government approved the Savanna burning methodology as a carbon farming methodology, leading to a large industry dispersed across remote landscapes in northern Australia. And as of this year, there were 70 projects across northern Australia worth around $50 million annually. So the brown areas indicate the location of the projects. Some of them are not active, and some areas which are active aren't on there, but it gives you a bit of an idea. Also, since 2015, there's been the development and acceptance of the lower rainfall methodology, as it's called, and that allows carbon projects to go down to that 600 millimetre isohyet line, so that's that lower line. So there is a growing opportunity for the continued expansion of this industry. And what's really critically important in terms of what I'm trying to do with my project is to develop tools which will have an on-ground impact on the management of these fires. So I'm really hoping that there will be some efficacy or use of what I'm trying to achieve, because currently the capacity to manage these fires is highly variable. So just in summary, early dry season fires have significant beneficial impacts, and the mitigation outcomes have been proven. So it's something that we really need to focus on. But in order to improve the quality of these fires, we need to understand fire behaviour in northern Australia. Currently, the main data set that is used, or empirical data set, is from NAFI, and it's what we call the time sets last burnt data set. So you can see an example on the right there, and it shows how long since a bit of country was burnt. And based on that, we can, the fire managers think about the fuel load accumulation in those areas and use that as part of a suite of local knowledge to base their implementation of their early incendiary curves. However, what stops and propagates fire in these landscapes is a lot more complicated than that. So you can see in this case, we've had a fire come up and been stopped by this quite a little sort of road break or fence line. So anthropocentric breaks are quite important, but they don't always work. So this is a fire from about 2 months ago, south of Katherine, southwest of Katherine, and it's just raced across the Victoria Highway. So why did the fire stop in that first instance but not in this instance? In this case, we can see a fire's been pulled up by just a little creek line. So why that creek line? Why was that effective in this case? Fires also stop due to fire weather, so most fire managers are hoping that the burns they place will burn enough country to form a contiguous break or a large enough patch, but they're generally hoping the fires will go out overnight, so fire weather is an important factor. So you can see in this case, there's nothing, we can't see anything specific which is pulling up the fire, but it's probably just gone out overnight as the temperature has dropped, the humidity has increased and the wind speed's dropped. Similarly in this case, you can see the fire's just gone out sort of naturally, but we've got this little sort of wick or sort of tongue of fire that's come out there. So why has that happened? Well, I don't really know. And so I did quite a lot of aerial validation work for NAFI, flying around in helicopter. It was a lot of fun, collecting validation points to make sure what I'm doing from the satellite imagery is accurate. And when I was doing this, I was seeing a lot of fires like this, fires burning against the wind. Now all the classic models say fires burn with the wind. All the fires I saw were burning against the wind. In this case, this was a fire burning down a slope against the wind. You look at the classic models, hopefully that's big enough to see, but it shows you have an ignition point here, the wind's going this direction, and the fire burns like that. Now, I've never seen a fire like that. All the fires I see are burning down hills against the wind or, just doing whatever they want. So the point is that fire spread is complex, and managing fires in these landscapes is difficult. It's not an easy thing to do. And a lot of people... And I think it's important to understand how complex this fire system is. So fire spread operates on multiple spatial and temporal variables. So we've got wind speed, which can fluctuate from gusts between minutes to seconds or change through the diurnal cycle. Like temperature and humidity, the fire weather changes seasonally, but it also changes through the day. Also, you get sort of micro-topographic effects, both with fuel load and also these fire weather events. So the way that these systems work over these multiple spatial and temporal scales, it's a classic complex system where you get these emergent properties that are hard to predict. For example, with fire, you can get a single ember. A gust of wind could take a single ember over what you thought was a contiguous break in the fuel load, whether it be a fence or a road. If that single ember flies over that road, it will take that system into a whole new state. It's sort of like the butterfly effect. We had a really good example of unexpected emergent outcomes from complex systems last week when we got this guy. Who predicted that? So anyway, this wildfire started now, and hopefully, as the global political system enters a new state, it won't be scorched earth, but we wait to see. So if we can't even predict a simple thing like that, how can we go about predicting where the fire's going to be in the next few weeks? And I find it really interesting as well. People always ask me, your model needs to be predictive. We need to know what's going on. And I say, well, if you can predict for me what the weather is going to be like at 3 p.m. next Thursday afternoon, then I might be able to do the same thing. It's like, well, no, you can't predict the weather like that. Well, but fire is related to the weather. We can't predict the weather. How can we do long-term predictions of the fire? So looking at current fire behaviour models, are they fit for the northern savannas? Most of them are derived from empirical rate of spread algorithms. So you see that little picture there, that's from Anna Baru, 1993. This guy Cheney lit some fires in these pre-prepared paddocks, and they measured how long it took for a fire to move over those landscapes. Now they're really useful for supporting emergency response type activities. Now it's great to have some sort of idea based on the fuel loads and weather conditions when a fire is going to arrive at a property or a road. Will it be that afternoon or late in the evening? You need that sort of information, or at least the best guess, to support, whether you put fire crews in there or you evacuate your fire crews or you close the road. But not quite so relevant for a lot of northern Australia, where the main issue is not life and property. The main issue is developing these little landscape scale fire mitigation burns. Most of these, the traditional fire models are based on relatively small spatial and temporal scales, so it's over a few days at the most, over tens of kilometres at the most. But I regularly see fires in NAFI in northern Australia that burn over months, and like a fire recently in the Kimberley burnt 1 million hectares. They're massive. So most of these are also deterministic. You feed in a probability and it gives you you feed in the variables and it gives you a definite output. So they don't deal with complex systems, which what fires are. They also require high spatial and temporal data sets, which we don't generally have in Australia, in Northern Australia. And they're predictive and not explanatory. So they'll tell you an output, but they don't explain why the system is behaving in that way. So they're not very useful generally for teaching and education. So most of these are focused on applications being used by a centralised agency in southern Australia for people with training in how to use these models. The main ones are Aurora, otherwise known as Australis, developed for southwestern Australia, and the other one, Phoenix, developed for southeastern Australia. But both of these have limited or almost no application in Northern Australia. And I would argue that actually they're not that appropriate for the applications that we need in Northern Australia. There's also sort of growing criticism of this form of modelling. The sort of linear mechanistic models can provide a false certainties because they're telling you, okay, this is what's going to happen. Now, if they're wrong or if they under-predict the movement of fire, you can have some really bad outcomes. And increasingly, some of the people who have made their careers out of fire modelling in southern Australia, including Tolhurst and Miguel Cruz, are starting to question the way their own models are being used. They would like to see them being used more in an exploratory way as opposed to a predictive way. But the problem is we're hardwired to want to know what's going to happen and when it's going to happen. Even in a world where everything is, things are generally complex and unpredictable. We really wanted to know that Trump was not going to win. But unfortunately, we were wrong. So I think it's really useful within this. There's a need to develop sort of complex systems thinking rather than wanting to know the outcome, how to explore how the processes work, how to understand boundary states and the probabilities of outcomes rather than having to know with certainty. I really like this graphic as well. This has come from work from Miguel Cruz. It's the science and art of wildfire behaviour prediction. It really emphasises the need for local knowledge, personal fire behaviour experience and professional judgment to calibrate those models if they had to have any sort of predictable or accuracy. So it's saying that it needs to be a participatory process. So what would a useful fire behaviour model for Savanna landscape look like? I would argue it has to be explanatory. It has to be built around understanding processes over prediction and understanding how the key variables affecting fire spread, how they work and how, importantly, they interact. It needs to be a scenario gaming tool so people can be used for strategic burning, planning and communication. And focused not so much on that rate of spread modelling, but more about trying to understand what barriers in the landscape will pull up fires. And I like this virtual lab idea, like a way that we can experiment with the way the system works. It's a good way, a tool to think with, I guess. It's the way I'm sort of approaching this exercise. It also needs to be engaging. It needs to work across cultures. So that's where I see the sort of 3D interactive support tool. Something like the sim table would work in this context. So what am I actually going to do? So these are the 4 research themes, as I call them, that I'll be focusing on through my candidature. Theme 1 aims to assess what landscape features act as barriers to fire spread in Northern Australia. Theme 2 is developing one of these cellular autonomous geosimulation fire spread models for Northern Australia. Theme 3 will explore the role of 3D geosimulations for integrating PUS through GIS and improve fire management.
Don't worry about us.
Yeah, no, you're all good. You're all good. Welcome, welcome. And theme 4 will investigate geosimulations for sort of teaching and learning outcomes. So just a little bit more detail. Theme 1 aims to assess what landscape features will act as barriers to fire spread in Northern Australia using long-term satellite-derived fire history. So fire edge metrics will be developed through this research, and they will then become an underpinning layer for the geosimulation model. Most work to date when looking at fire spread is focused on fire propagation. There's been not much work anywhere in the world really looking at fire extinction, what puts fires out, which is interesting. Owen Price, I mentioned before, he's done a little bit of work in Northern Australia, but looking to expand that work. And we have a real interesting opportunity here. So due to the high fire frequencies of the Savanna landscapes and the fact that in Kakadu we have over 30 years of high resolution Landsat data to look at how fires work in those landscapes, got an opportunity to do some interesting analysis. So what you can see on the right there this is just some initial work that I've done, exploring. So what I've done, I've taken the edges of fires for about 20 years of that fire history and overlaid them on top of each other. So what it's highlighting in the red there are areas where fires have stopped in that landscape multiple times. And it's starting to pick out some key features. I don't know what those key features are yet, that's what I'm going to do, but there's clearly something going on. And I should acknowledge that this work was actually started by a fellow called Ben Lewis, who some of you might know. So I'm hoping to continue to work with him on this project. What I'm also keen on doing is seeing what the potential is to take the work we do in Kakadu and see if we can expand it across most of the Savanna landscapes using MODIS data. So the research questions, we how to develop a landscape scale fire edge metric to identify landscape features that extinguish fires. How does that correlate with a range of terrain and infrastructure features on different seasonal conditions? And what is the correlation between the landscape scale fire edge metric and a MODIS scale fire edge metric? I'd also be interested in looking at what sort of level of fire frequency that would be related to rainfall gradient would be a limiting factor on trying to get useful data sets out of this. Theme 2, so developing this geosimulation of fire spread, a model optimised for planning and capacity building applications in the Savanna landscapes of Northern Australia. So this is sort of a spatial modelling or geosimulation method. So it aims to facilitate the broader use of fire-related empirical data sets, allow the visualisation of complex fire behaviour in relation to relevant landscape fire weather and variables, importantly it supports participation and communication around fire management to a culturally diverse range of land managers. So the key questions are trying to work out the key biophysical fire weather variables that affect fire spread, how I would code these into NetLogo, and what forms of interactivity would facilitate the scenario gaming of fire spread in a way which is useful. Okay, this is the way that I've been developing the model to date. I won't go through all of this at the moment, but the key factors I'm looking at is fuel load as a function of time since last burnt and grass layer. I find a detailed topographic wetness index. There's a topographic curing layer, time of day, fire danger, of course wind direction, speed and slope, time since ignition. So all of these things are going in to determine a burn probability for each cell as the model runs. This is an example of the model I've been working on. So we've got all these widgets and dials on the side here. And that allows you to interactively sort of muck around and play with it and see what sort of outcomes. So it's sort of like that virtual lab format for experimentation. Okay, hopefully this will work. I just want to show you a couple of examples of how the fire spread model that I've been playing with works in practice. So this is an example from the Tiwi Islands where I've got multiple fire spread points running on 4 different wind speed settings. So this is about understanding those sort of boundary conditions. So you look at no wind, those fires haven't gone anywhere. Sarah. Sarah from Sumba. Okay, we can see down the strong wind speeds down the bottom there. It's burning straight through all of their great acacia magnum plantations and burning up. So it's about understanding the boundary states. I'm not necessarily saying this is exactly what the fires are going to do, but it does allow you to understand what the potential outcomes. So this is another example. This is from Arnhem Land near Gumbalanya, and these are 4 fire weather conditions. So low would be sort of a late wet season, and the very high down the bottom there is a late dry season fire. So we're looking at the range of conditions in between. And significantly, what's happening with both the high and very high fire weather conditions is they're burning up into these long unburnt savanna landscapes. So it's clear you need to be very careful when trying to lay down your incendiary lines, what the weather conditions are, because fires can escape. So that's about understanding boundary states. This one is looking at multiple runs of the same fire. So we're dropping some incendiaries along the road, or maybe it's a roadside burn, under reasonably mild fire conditions. When the model goes to night, to a darker display, that's going into night. So most of the fires are going out overnight and they're being contained by the road. So we're getting some nice sort of mitigation burns there. But occasionally you can get these wind gusts and they're a little bit unpredictable. So in this case we've got a gust of wind and it's taken the fire over the road and it's taken off again. And what this allows us to do over multiple runs of exactly the same fire weather conditions, we can have a look at burn probability. So this gives us a sense that in most cases, under those fire weather conditions, we're going to get a nice burn across the road. But we need to be aware that fire is intrinsically an unpredictable character, and you can get these cases if you get these wind gusts. We can go across the road. So these are this is what people managing fire in the landscape, they have to deal with that all the time. And often there's a very short period, it may only be a couple of weeks, when things are cured enough to drop your incendiary, so you're going to get a good burn, but your fires won't burn overnight and take off. So it's a really fine line. It's difficult. Aim 3 aims to explore the potential role of fire spread model in a 3D tactile application for supporting capacity building. This effectiveness we explored through case study application. So this work will be largely a literature review and a case study. So the setup is the 3D display, whether it be sand or one of these 3D printed displays, is on a table. A digital projector displays the geosimulation model over the top. I've got an infrared sensor and infrared light pen, which allows interactivity directly with the model. So this is an example of a 3D print. This is a 3D printed niblook. This is the 3D print with a projected display, and this is my 8-year-old daughter sparking up some fires with the light pen over the top. And she loves playing with this. It's sort of quite fun to scorch these landscapes. This is an example of the same thing but projected over a sand pit. And the fun thing with the sand and using the infrared light detector, you can actually use a cigarette lighter to initiate a pixel. So you can go and light it up. The infrared detector will detect the light from the cigarette lighter and initiate fire spread over the landscape. So that adds a bit of theatre to the whole thing, which I think is important because it's around engaging audiences which may not be so interested in what you're doing. And if you can have that bit of theatre and get people thinking and talking, I think it can be a really useful approach. So the research questions, primary research questions here, how are fire spread models being used and what are their applications currently available in Northern Australia? I can answer that by saying not much. How is the North Australia fire spread geosimulation, the one that I'm working on, being applied, and what are the benefits and challenges to its application for improving planning capacity building? Does 3D tactile representation, is that important for supporting sort of capacity building? So over the next few years I'll be building on collaborations with fire managers to help me develop the model going forward. So I currently have partnerships with the Tiwi Land Council, Kimberley Land Council and the Bushfires Natural Hazard CRC through their North Australian Fire Management Curriculum program. And I'll be exploring the outcomes through sort of structured open-end interviews, exploring how the models worked. So that's all probably far too much for one PhD, but I thought I'd add some more in just to make it difficult for myself, but also because I'm quite interested in this as well, I guess. It's trying to understand how this sort of 3D tactile representation would improve teaching and learning outcomes. So as I said, I think there's a real need for understanding complex system and complex system processes. So I'll be testing this in the context of teaching fire management. So there'll be a literature review and controlled learning experiments. So the research questions are, does interactive geosimulations increase students' understanding of fire processes and management considerations? Is this understanding enhanced by 3D representations? Does the tactile engagement assist this? I have a theory that the sand might be better than the actual 3D printed models because you actually got to get on your hands and knees and physically make it. And I think that tactile engagement could actually be more beneficial in 3D print, but something to try and find out. So how does the sand pit compared to the 3D printed model? So I'm proposing this will be a qualitative and quantitative research for assessing the learning outcomes. There will be a literature review around multisensory and multimodal teaching approaches and associated learning benefits, and then hopefully some classroom experiments. So looking at a number of learning approaches using the geosimulation and 3D display applied to different groups, pre and post testing of what they learned from the simulation to assess what they got from that. So I'm currently exploring collaborations with middle school and also potential sort of tertiary level collaborations with colleagues at this university. high school's sort of out. My oldest daughter's in high school and it's all locked down. You don't really have much of an opportunity to do additional teaching in high school, but there may be chance in middle school. So that's the overview of what I'm doing. And this graphic, which is a bit small to see, so just to be clear, I'm doing this part-time, so I work full-time, and but I see what I'm doing sort of harmonises quite directly with what I'm doing already, particularly with NAFI, with the Darwin Centre of Bushfires Research. So it will sort of work in collaboration, work there.